Linear relations. In everyday's life, we see so many changes which involve the linear relation among two quantities. Suppose we have two quantities y and x, and y is changing at a constant rate with respect to x. Then we say y and x are related linearly. To illustrate, if you see a car is moving on a road with a constant speed, and if you plot the distance time graph, you will get a straight line like this. The graph will be a straight line graph. Such a graph is called a linear graph. So this chapter deals with the linear graphs, and in this chapter we will see how we plot the graph by the equation of the quantity. In the next chapter we will see how we obtain the equation from the graph. Got it? The present chapter deals with plotting the graph from the equation, and the next chapter will deal with obtaining the equation from the graph. So in this chapter we will see the skill how to plot the graph when the equation among two quantities are given. Suppose a equation of current and time is given and you have to plot, then we will learn the skill how we will plot the IT graph. Okay, these are the skills which we will learn in these lectures, how we will plot the IT graph. Suppose the time period of the pendulum is given, so we will see how we can plot t versus root L graph, how we can plot t square versus L graph. Now if you see, when we say any function is a linear function, already we have seen what is the meaning of the function in our basic mathematical tools first lecture, functions. When there is a relation among two variables, say y and x is the independent variable and y is the dependent variable, then we say y is a function of x. Now suppose y is a function of x, and as I told you, the change in y is directly proportional to the change in x. What it means, when you are changing x, of course y will change. The change in y is directly proportional to the change in x. Okay, if you are changing x 5 times, the y will also change 5 times. Then such a relation is called linear relation. Okay, such a relation is called linear relation. So we can express a linear function by the equation y is equal to mx plus c. Y is equal to mx plus c. Here x is the independent variable, okay, y is the dependent variable. For the model we are taking x and y. Just for the understanding and analysis, we are taking the model, the independent variable as x and the dependent variable as y. When we apply these skills in problems, then the independent and dependent variable may change. Like sometimes we have velocity and time, sometimes you will have position and time, sometimes you will have pressure and temperature. Okay, so first we will gain our understanding by the model of y and x, treating x as the independent variable, y is the dependent variable, and when later on when you come to the application of the same skill in the problems of the subject, in the problem of science, then you will see whatever is the independent variable, that variable will play the role of x, and whatever is the dependent variable, that variable will play the role of y. So whenever you have any equation of this form where the power of x is 1 and m and c are constants, the coefficient of x is constant which is written as m, and there is another separate constant which is written as c, then such an equation is called a linear equation. If you see some of the examples like y is equal to 4x minus 5, y is equal to 5x, y is equal to 5 minus 9x, y is equal to minus 4x. See, c can be 0. If you see illustration b, so there is a coefficient of x, but there is no c, so c can also be 0. So all these kind of relations are linear relations. Got it? If you are having y is equal to a, suppose you have some equation y is equal to a, where a is a constant, say like y is equal to 5. So obviously you can see the equation, the value of y is independent of x, correct? The value of y is not depending on x. So we say y is a constant function. Here y is independent of x, so we say y is a constant function. And as we have seen in the polynomials, a constant function can be treated as a polynomial of any variable with 0 degree. So you can say if y is some constant, you can say y is a function of x with power of x as 0. Okay, this already we have seen in the lecture of polynomials, correct? So whenever y is some constant, it is a constant function. The graph of this function will also be a linear graph. We will see later on which kind of linear graph it will be. So I guess it is clear, whenever y and x are related by the linear function like this, y is equal to something, some constant x plus c, then such a function is called a linear function. Now see how we plot the graph of a linear function. So now we have learned to identify the equation of a linear function. This will be the equation of linear function, and whenever you have a linear function, always remember, whenever you have a linear function, the graph of a linear function will always be a straight line. Got it? And when you plot the graph, we know on the vertical axis, we plot the dependent variable, that is y, and on the horizontal axis we plot the independent variable, that is x. And the graph is called y versus x, or y against x. Okay, so the graph of a linear function will always be a straight line. So whenever you have a linear function, at an instant you can say the nature of the graph would be a straight line, rectilinear graph. Okay, now there are important parameters. First is the slope or gradient. Now let's see what is slope. When you are making a straight line, say this is your x axis and this is your y axis. Okay, and we have a straight line like this. So let's see what is the angle subtended by the straight line with the positive side of the x axis. I'm saying with the positive side of the x axis, that is this angle theta. So slope means the inclination, so we usually write slope as m, and this will be equal to tan theta. Got it? So this is the measure of the slope of the straight line. Got it? And the same straight line has a constant slope. Same straight line has constant slope. The slope will not change anywhere on the straight line, because you see at any point you see the inclination is same. So same straight line has the constant. So if your graph is like this and the straight line is like this and this angle is 60 degree, then the slope will be m, that is how much? Tan of 60 degree, that is root 3. Got it? The line is making an obtuse angle with the x axis. Suppose this is a y axis, this is x axis, and this is the line, and this angle is 120, or say this angle is 60 degree. So slope will not be tan 60 degree. Never do this mistake, because we have to take the angle with the positive side of the x axis. So this angle will determine the slope. The slope here would be tan of theta, that is tan 120, and we know the basic formula. You can write tan 120 as what? Tan 180 minus 60, and tan 180 minus 60 will be minus tan 60, that is minus root 3. So this line will have a slope of negative of root 3. Whenever you have a linear relation, the graph will be a straight line. That's why slope is constant everywhere. So that's what we have seen. In a linear relation, the rate of change is constant. Y is changing at a constant rate with x. Got it? Y is changing at a constant rate with x. The rate of change is neither increasing nor decreasing. Second parameter is the y-intercept, or the vertical intercept. This intercept is given by this constant, which is a separate constant. The coefficient of x will give you the slope. If in the straight line you have 5x, so the coefficient of x is what? 5. So the slope will be 5. And this single constant term, this will give you the y-intercept. This will tell you where the line is cutting on the y-axis, this point. Okay, so this length is c. This is giving you the coordinate of the intersection of the line with the y-axis. So basically there are two parameters when plotting a straight line. First you identify the slope and then you identify the vertical intercept. Now let's see slope of the straight line. So we have seen whenever you write the equation in this form, y is equal to mx plus c, then the coefficient of x will give you the slope. The coefficient of x means the coefficient of independent variable. So if you're writing 5y is equal to 3x plus 2, so the coefficient of x is 3, the slope will be 3. If you're writing y is equal to 4 minus 5x, so here the coefficient of x is what? Minus 5, slope will be minus 5. If you're writing velocity as 3t, 2. Now here see, I'm changing the variables. Now we got, in place of y we have velocity, in place of x we have t. So here you have to find the slope. Of course you can say this is a linear relation because v is depending on the first power of t. So this is a linear relation and slope is given by what? The coefficient of the independent variable. So what is the independent variable in this case? T. So slope will be 3. Okay. Now let's see. We can have positive slope, we can have negative slope, we can have zero slope. So you must have these construction on your fingertip. Whenever you have a positive slope, the line will ascend. The line will ascend as we move towards right. So if this is yx and you are going on the right side, always we move towards right side because the independent variable is this. And if the line is going up, so we say the slope is positive like this. Here if you see like this, again see the line is going up. It doesn't matter whether line is below x-axis or above x-axis, it must go up. So here also the slope is positive. If you see this graph, here also the slope is positive. Okay. So whenever the line goes up on moving towards the right side, we say the slope is positive. In the same way, if you are moving to the right side and the line goes down, say like this. So say when I am going to the right side, the line is going down, correct? Slope is negative. It can be like this also. See, I'm going right side, the line is coming down, slope is negative. Okay, all these graphs are illustrating negative slope. We can have something like this also. I'm going right side, graph is coming down, slope is negative. Okay. Okay, what is a zero slope graph? M is equal to 0. Zero slope means M will be 0. So your equation will be simply y is equal to what? C. Or you can say y is equal to A whatsoever. Where this thing or this thing is what? Here I have written, if you put M0 you will get this equation. And here I have written as the illustration where A is constant. So earlier, in such kind of graphs, y will be independent of x. Y will not depend on x. So if you are changing x, y will not change. So you'll get a horizontal line passing through y is equal to which value? C or A. This is the graph of which function? Y is equal to C, correct? Now let's see. So when you will have infinite slope in the graph, so your angle will approach 90 degree, correct? Because tan 90 approaches infinity. So the straight line will be vertical, something like this. So for this, slope is what? Infinity. And the equation would be x is equal to a line passing through A. So equation like this, you will get a straight line with infinite slope. Suppose I am saying x is equal to minus 2. So you will make a line where passing through x is equal to minus 2, and of course the line will be perpendicular to x-axis and parallel to y-axis, and the slope will be infinite. Okay. So whenever you have an equation of the form x is equal to something, that is a vertical line, the slope will be infinite. Whenever you will have the form y is equal to some constant, that is a horizontal line, slope is constant. So you got how to make the inclination of the line. by the sine slope. How to make the intercept? So as I told you, when you're writing this equation y is equal to mx plus c, this separate single constant give you the intercept, right? It can be positive. Suppose c is positive, it means the line is cutting the y-axis above the origin, correct? If c is positive, it means the line is cutting the x-axis above the origin. If c is negative, it means the line is cutting the x-axis below the origin. If c is 0, it means the line is passing through the origin. There is no intercept. The line is passing through the origin. So whenever we don't have that isolated separate constant term, the line always passes through the origin, like y is equal to 5x, y is equal to 2x, y is equal to minus 3x. All these lines will pass through the origin. Got it? Now let's see the skill. How we will plot. As I told you in this chapter, we will learn the skill plotting the straight line graph from the equation, linear equation. So first of all, you have to identify which is the dependent variable, which is the independent variable. In mathematics, it is quite straightforward. X will be the independent variable, y will be the dependent variable. But in physics, you have to identify. Sometimes you have to plot the variation of velocity with time, current with time, position with time, flux with time, okay? Or sometimes say force with position. So you have to decide which variable is the independent variable, which is the dependent variable. As I told you, just for understanding, we are taking the prototype, the model as y as a function of x. Yani, that means we are dealing with a model in which y is the dependent variable and x is the independent variable. So write your equation in this form. Write your equation in something this form. Dependent variable is equal to some constant into independent variable plus some another constant. This constant is playing the role of m, that is slope, correct? The coefficient of the independent variable. And this another constant which is isolated, separate, without any variable, this is playing the role of vertical intercept. Got it? You can plot the graph. We have to plot y is equal to 3x plus 4. Got it? So if you compare it with the standard form y is equal to mx plus c, so of course you can see it's a linear relation, so graph will be a straight line. So m is coming to be 3 and c is coming to be 4. So we will have positive slope as well as positive intercept, correct? Positive slope means we have seen right now the graph will go upward, and positive intercept means it will cross the y-axis above the origin. So the graph will be like this. What will be this point? So this is the y-intercept, which is 4, and you can also plot this point. So this is the value of x when y is equal to 0, correct? Value of x when y is equal to 0. This is also called x-intercept. So you can find it from put y is equal to 0, because see the graph is intersecting with the x-axis, and at each point on the x-axis y is equal to 0. So put y is equal to 0, so you'll have the equation 0 is equal to 3x plus 4, so x will come to be minus 4 by 3. So this value is coming to be minus 4 by 3. You can plot it. Okay. Straight line graph. And whenever you are plotting the straight line graph, always mark both the intercepts. And in the side space, you can also write the slope, that is 3. Got it? Now let's see the illustration set 1. Plot the following straight line graphs. Even if it is not given a straight line, we can judge from the equation that graphs would be straight lines, being the linear functions. So A is y is equal to 4x minus 5. I am comparing it with the standard form. So M is coming to be 4, C is coming to be minus 5. I will have positive slope and negative intercept. The slope is positive, graph will go upward, and your intercept is negative. So my graph will have a nature like this. Okay, and this will be what? Minus 5, and this value is the value of x when y is equal to 0. So if you put y is equal to 0, I will get 4 of x minus 5 will be 0. So x will come to be 5 by 4, correct? Now if you see the second equation, 3x plus 5, y is equal to 3x plus 5. Again, it's a linear function. So m is what? 3 and c is 5. So we have both the slope is positive as well as the intercept is positive. So I will having the graph cutting the y-axis above the origin and going upward. So your graph will be like this, and this value is what? 5. And what will be this value? This is the value of x and y will be 0. So 3x plus 5 will be 0. So x will come to be minus 5 by 3. Okay. Third graph is minus 2x. So if you compare it with y is equal to mx plus c, so y is coming to be minus 2x plus 7. The slope is having a value of minus 2. That is the coefficient of x, and the intercept is 7. So we will have, because the function is linear with negative slope and positive intercept. So the graph will be like this. Okay, and what is the intercept? 7, and slope will be minus 2. And what will be this value? The value of x and y will be 0. So you can 0 is minus 2x plus 7. So x will come to be 7 by 2. Got it? Last one is y is equal to minus 6x minus 4. So let us again compare it with the standard form. So m is coming to be minus 6 and the intercept is coming to be minus 4. So we have both the quantities negative. The slope as well as the intercept graph would be going downward and cutting the y-axis below the origin. So this point will be minus 4. And what will be this point? This is the value of x when y will be, so 6x minus 4 will be 0. So x come to be 4 by minus 6, that is minus 2 by 3. Got it? And the slope here is minus 6. So this is, I guess now you are very much fluent about these simple equations whenever you have a function of x. You will identify, first you will write the equation in the form y is equal to mx plus c. You will see what is the value of m, what is the value of c, and then you have learned how to make positive m, positive c, negative c, 0 c. Now see these kind of graphs. See in these kind of graphs, the single constant term is missing, correct? Single constant term is missing, and whenever we have the form like this, it means the graph passes through the origin, correct? Either upward or downward depending on. So A is what? Y is equal to 4x. So you will have a graph. If you compare it with the standard form, what we will have? We will have y is equal to mx. M is 4, that is positive. And c is 0, correct? If you compare it with this form now. So c is coming to be 0. So the graph will go upward, passing through the origin like this. And slope is how much? 4. Minus 3x. See B. Y is equal to minus 3x. So if you compare it with the standard form mx plus c, so m is coming to be minus 3, c is coming to be 0. So you will have, again the graph will pass through the origin because the value of c is 0. and since slope is negative, it will go downward -3. Okay. Y is x by 2. So if you compare it with this, slope is coming to be positive, that is half, and c is coming to be 0. So again the graph will pass through the origin and line will be upward, and sloping to be -1 by 5, and c is 0. The graph will be going downward, again passing through the origin. Okay, now let's see one important thing. If you want to make the two graphs on the same figure, so you know when the slope is positive, the graph goes upward, correct? And this angle denotes the slope. M is equal to tan theta. From 0 to 90 degree, tan is increasing function. What it means, if theta 1 is greater than theta 2, then surely you can say tan of theta 1 is greater than tan of theta 2. Got it? Tan of theta 1 is greater than tan of theta 2. So if you have two lines, and this is theta 1 and this is theta 2, so surely you can see theta 2 is greater than theta 1. So tan of theta 2 will be greater than tan of theta 1. That is, slope of 2 will be greater than slope of 1. Okay. So if you are two lines on the same graph, then the graph which will have greater value of slope, the greater value of slope will be inclined more upwards. Like in A, y is equal to 4x and y is equal to 3x. In both the graphs, value of c is 0. That means both the graphs are passing through the origin, correct? Both the graphs would be passing through the origin. But they have difference in the values of m. So as I told you, here m is 4, here m is 3, m is the coefficient of x. So which will have a greater value of m will have a greater inclination. So this is the graph of y is equal to 4x and this is the graph of y is equal to 3x. Got it? Now let's see the comparison of two graphs with negative slope. See, whenever we have a negative slope, we know the line will descend. The line will go where? Downward as you move on the right side. So suppose we have this as the y-axis, this is the origin and this is the x-axis. And if you want to label the slope, this angle will give you the slope, the angle with the positive x-axis, say theta. So you can clearly see theta is obtuse angle. So slope will come to be negative, correct? This is your obtuse angle. The slope will be tan theta, which will come to be something negative. Okay. Now while making two graphs on the same sketch, we have to be very fluent in comparing their inclination. So say I am comparing the inclination with the horizontal, down inclination with the horizontal. Let this angle be phi. This is the down inclination with horizontal, and this I have to compare with the value of m. So see if this angle is phi, this angle will also be phi. So here you can write theta plus phi is pi radian. So I can write theta is equal to what? Pi minus phi radian. So tan theta will be tan pi minus phi, correct? And we know tan pi minus phi is minus tan phi. So tan theta is minus tan phi. And tan theta is negative. And if tan theta is negative, so of course your tan phi will be positive, because tan phi is coming to be minus tan theta. So if tan phi is positive, and same you can say as modulus of tan theta, correct? It means tan theta is minus 3, so tan phi will be 3. If tan theta is minus 1, so tan phi will be 1. If tan theta is minus 4, so tan phi will be 4. Okay? Is the slope in the equation? Let's see the first thing we have to judge in the equation. If we have y is equal to mx plus c, got it? And m is negative. M is negative. The line will go downward, and I am not concerned with this angle, I am making this angle, the downward inclination, with the horizontal as what? Phi. So tan phi is coming to be what? Mod of m. Got it? Tan phi is coming to be what? Modulus of m. Got it? This is a fingertip which we have to keep in mind. That is a background which we have seen how we are coming to this fingertip. This is the fingertip point for application. Mod of m. Higher the value of mod of m, higher will be the value of tan phi, and you know from 0 to 90 tan is increasing function, so higher will be the value of phi. Greater will be the inclination. So if you have two graphs, like say y is equal to minus 3x and y is equal to minus 4x, correct? So here m is equal to what? Minus 3. Here m is equal to what? Minus 4. Here mod of m will be what? 3. Here mod of m is 4. So the graphs on the same sketch. Say I am taking the starting point as same. So with the horizontal like this, I will have greater inclination for greater modulus of f. I will have greater inclination for greater modulus of f. So this will be what? Minus 4x, and this will be what? Minus 3x. This is your FTP, fingertip point, which you will remember. Now let's see, this we have seen the basic skill, the model, how to plot the straight line graph. Now let's come to the real application in physics. See, while plotting the graph of a quantity against time, first thing remember, whenever you are plotting some graph against time, like velocity time graph, position time graph, current time graph, unless stated in the problem, you will assume the initial time to be 0. Initial time to be 0, that means what? That means you will omit the left hand side of the graph. We won't plot anything on the left hand side. It is not necessary that always the initial time is 0. That's why I said unless it is stated in the problem. If it is given in the problem that you have to take initial time something else, then you can start from the left hand side. But if nothing is given, so you will start the graph from like position time graph. So you will start from the origin. Number 2, slope may or may not have a unit. Many times I say students say the slope will always be unitless. It is okay in mathematics when you are dealing with the numbers like y and x. But in the graph, slope may have a unit. See, when you are writing a graph equation like this, velocity is mt plus c. So by the homogeneity, all these three terms must have the same unit, same dimensions, correct? So v will be equal to what? mt. So m will have a unit of v divided by t, and v is meter per second and time is second. So the unit of slope will come to be meter per second square. So when you are dealing with the quantities, physical quantities, always remember slope may or may not have a unit. Whenever you are plotting two quantities, so this quantity is z and this quantity is v, anything, then the slope unit will be unit of z by unit of v, vertical unit divided by horizontal unit. So remember these two things. Plotting the graph from t is equal to 0 unless some other thing is mentioned in the problem, and slope may or may not be associated with a unit. Okay, now let's see some of the illustration. The velocity of a particle is v bracket t. We remember velocity as a function of time is 5t plus 2 meter per second. Remember, this does mean that you are multiplying with v and t. You remember this basic notation of function we have seen? This is velocity as a function of t. In some books, it could also be given like this, without mentioning t in bracket. Both are carrying the same meaning. T graph, T graph, or V versus time graph, or V against time graph. First key point is, whenever you are plotting time is always an independent variable. Time is always an independent variable that is taken on the horizontal axis. And this is the dependent variable. Okay. Since nothing else is initial time 0, so we won't be taking the graph to the left side of the origin. Okay, next is, if you see here, what is the dependent variable? V. Correct? And what is the independent variable? T. So in the model we have seen y and x, and as I told you earlier too, when you are applying these skills in science, in applications, you won't meet every time y and x. You will be meeting the physical quantities. Like here you are meeting velocity and time. So you have to identify which quantity is playing the role of dependent variable, that is y of your model. Which quantity is playing the role of dependent variable, that is y of your model. Which quantity is playing the role of independent variable, that is x of your model. So here y is, in place of y we have v. In place of x we have t. So I can write the prototype equation. There I have written y is equal to mx plus c. There I have written y is equal to mx plus c. In this case, in place of y we have what? V. In place of x we have t. So I have the equation v is equal to mt plus c. And if I compare the given equation with this, so my slope is coming to be 5, my intercept is coming to be 2. So I will have a graph which will have a positive intercept, that is, it is passing above the origin, and positive slope. So your graph will be like this. And what will be this value? So this value will be what? This value is the intercept 2, and here you can write the unit. In y-axis we were not writing the units, remember? But while you are plotting the physical quantity, write the unit, meter per second, and here second. The slope of the graph with unit. What is the slope of the graph with unit? Now we have to find the slope with unit. The slope is 5. And what do you think, what will be the unit of slope? Right now we have seen how to find the unit of slope. Can you tell me in this graph what will be the unit of slope? So unit is the vertical unit divided by the horizontal unit. So I'll get meter per second. So your slope will come to be 5 meter per second square. This is the answer. So first one is the plotting the graph, second one the slope unit. At what time the velocity will be 0? What do you think? At what time the velocity will be 0? Now see, the graph is going upward, so it will never cut the time axis. The graph is never cutting the time axis. It will be going upward forever and ever. So the velocity will never be 0. The answer is never. Got it? The basic tool which we use in the graph is for visualization. You can see when time is going ahead, the velocity is increasing, number one. Number two, the velocity is increasing linearly. That means the velocity is changing at a constant rate. So many things you can tell from the graph. The initial velocity is 2 meters per second. The graph gives you an instant visualization of many information. Now see, the velocity of two cars A and B are VA is 5t meter per second and VB is 7t meter per second. The same graph sketch the variation of two velocities with time. Again see, you have to make the variation with time, so no other information is given. So here I am plotting meter per second, here I am plotting time. I am skipping the left hand portion of the graph because I will assume initial time to be 0. So see here V is equal to MD plus C. Graph has this form. V is the dependent variable, T is the independent variable, and in both the equations C is 0, like VA is 5t plus 0, so slope of A is coming to be 5. VB is 7t plus 0, so the slope of B is coming to be 7. Both the graph will pass through the origin because in both the intercepts are 0, and both will have different inclination, and right now we have seen higher the value of M, higher will be the inclination upward with the horizontal, correct? So this will be VB, that is equal to 7t, and this is your VA is equal to what? 5t. These will be the two graphs. Got it? Okay, now say illustration 3. The velocity of a car is 2t plus 4 meter per second. Take the initial time to be minus 4 seconds. Now see here they have given that you won't start the graph from t is equal to 0. Instead, you will start the graph from t is equal to minus 4 seconds. So this is the time axis, the independent variable, and this is the velocity. Now again you can see a linear function. So this is of this form, mt plus c. What is slope? 2. What is intercept? 4. So we will have a graph with positive slope, graph will be going upward, and positive intercept. So it will go like this. This is the graph. And I have to start with where t is equal to minus 4. So what will the velocity as minus 4? When t is equal to minus 4 seconds, velocity will be how much? 2 into minus 4 plus 4. So velocity will come to be minus 8 plus 4. So velocity will come to be what? Minus 4 meter per second. So we'll have something here like this. Yes or no? So this is your minus 4, and this is coming, this is in seconds, and this is meter per second. And this value is coming to be how much? When we have t is equal to minus 4, it is minus 4, correct? When t is equal to minus 4, your velocity is also going to be minus. Number 2, when t is equal to 0, what will be the velocity? So this will directly be the intercept, 4 meter per second. And what is the slope of the graph? 2, unit will be meter per second square. So the graph question. See, now I am starting the graph from where? I am starting the graph from t is equal to minus 4 seconds, because it is given in the problem that I start the graph from t is equal to minus 4 seconds. What it means t is equal to minus 4 seconds? Many students think the value of t can't be negative. No. Already we have seen this thing in very much detail in the time lecture. Any negative value of t denotes an event occurring before t0. t0 is our choice where we are starting the stopwatch. So any negative value of t denotes an event occurring before t0. Like if 7 am you are taking t0, then 5:55 or 6:55 am would correspond to negative value of t. If you are taking 7 am as t0, then 6:55 am would correspond to how much? T is equal to minus 5 minutes. It means 5 minutes before the reference time. Okay. Now see the next illustration. The equation of an ideal gas is PV is equal to nRT. When we will study thermodynamics, then we will see ideal gas follows this equation. P is the pressure, V is the volume of the gas, N is the number of moles, R is the universal gas constant, and T is the absolute temperature, temperature in Kelvin. And Kelvin temperature is never negative. So whenever you are plotting something with absolute temperature, Kelvin temperature, the graph never goes towards the left side. So consider a sample of gas with fixed amount, number of mole. That is, this is constant, this we can't change. And fixed volume, volume is also constant, we can't change. And R is already a constant which is called universal gas constant. And you have to plot the various pressure of the gas with the temperature. Now see how we are applying the concept of a straight line graph. So we have to plot P with T. So first of all, in this equation, make P as the subject. So we'll get nRT by V, correct? nRT by V. Now this is basically the dependent variable, and this is what? The independent variable, correct? And since number is constant, R is constant, and V is constant, so all these three parameters will be constant. So you can see P is playing the role of Y, this constant is playing the role of M, and T is playing the role of independent variable. That is, you are getting the graph of something like this. Yes or no? So what do you think? When you are making P versus T graph, when you are making a P versus absolute temperature graph for an ideal gas, which kind of graph you will get? You will get a straight line graph, correct? Passing through the origin. Why passing through the origin? Because there is no intercept. C is having a 0 value. And what is the slope? The slope is number of mole R by V. So here you can write slope is what? Number of mole R by V. Got it? So this is, see, we are applying the concept of straight line graph in thermodynamics. Now see one more illustration. The time period of a simple pendulum is T is equal to pi root L by G. So when we have a simple pendulum, and this is the length of the pendulum, so this is the formula for the time period, and G is the acceleration due to gravity, which is not changing at a particular place. If you are performing an experiment and every time you are changing the length of the pendulum at the same place, suppose you are performing the experiment in your lab and each time you are changing the length of the pendulum, so of course the value of G will remain the same, correct? So we have to plot the graph of a T against root L. So we have the equation T is equal to 2 pi root L by G. Now I have to identify what are the variables. So I have to take this as dependent variable and root L as independent variable. So T is playing the role of Y and root L is playing the role of X. Okay, so what I can write? I can write as T is equal to 2 pi root G into root L, correct? And is it of this form? Yes or no? This thing is constant at a particular place, at particular place. So is it of this form? So you'll get a straight line graph. Yes or no? So if you are plotting here T and here root L and the intercept is 0, so graph will pass through the origin. And what will be the slope of this graph? So slope is the coefficient of the independent variable, not L, the independent variable which you are plotting on the horizontal axis. So the slope is 2 pi by root G. This will be the slope. Okay. Second part, we have to plot the graph of T versus L. Now we have to plot for T square versus L. Now we are no longer plotting T but T square versus L. So on the vertical axis, instead of T, we'll take T square and here we'll take L. And the formula is T is 2 pi root L by G. So I have to square because I have to get one side T square and L. So I'll get T square is 4 pi square by G into L. Now T square is playing the role of Y, L is playing the role of X, and these are constants. So this is playing the role of M, so you're getting the form Y is equal to mx. So again your graph will pass through the origin, we will get a straight line graph. And what will be the slope of the graph? The slope will come to be this coefficient of L, that is 4 pi square by G. This will be the slope. Okay, so these are the some of the illustrations where you have how we'll plot first of all identify that the graph will be straight line at the very first place when there is a linear relation between the two variables to be plotted, and then you can plot the graph and determine the slope. So in this lecture, after this lecture, what you need to do, first of all, attempt the related assignment MTD1. This is the first segment of this chapter. In the second segment, we will see how we will plot the piecewise graph like this by different equation, like the velocity is changing in different segments. Okay. So in the second lecture, subsequent lecture, we will develop the skill when different equations are given for different interval, then how we can plot these piecewise graphs. Okay. So but before that, we have to get full fluency over the skills taught in lecture 1. So go through the assignment MTD1, complete it. If you have any doubt, get in touch with me. Then after completing this, you can attempt the online test on our portal, the test code MTD1, to test your understanding and what you can say excellence over this lecture. And then you can go for watching the second lecture MTD2, in which we will see the piecewise graphs. Okay.